My name is Nidhi Chauhan. I'm assistant professor in Gyan School of Pharmacy. That is a part of Suresh University, Jaipur. So today we are going to discuss a topic that is your carboxylic acid. And in your carboxylic acid that comes in pharmaceutical organic chemistry first, in the farm second semester. So here, let's start. So today we are going to discuss or study about the carboxylic acid, and also we are going to learn about the method of preparation of carboxylic acid, and also we are going to study about the chemical reaction of the carboxylic acid, and student outcome will be going to know about what is carboxylic acid. That in the previous lectures also have told you that what is carboxylic acid, how is it, how it is obtained from the nature also, and it is present in the nature also, and it is how it is made up of the carboxylic, sorry, the carbonyl compound plus your hydroxyl group, that is both are attached in this, and there is a formation of this carboxylic acid. And what are the nomenclature of this carboxylic acid? And today we are going to discuss what are the method of preparation of carboxylic acid and how it is prepared on the in the industrial basis or on the laboratory scale. So here we are going to discuss or learn about the preparation method of carboxylic acid, as well as we are also going to study some of the chemical reactions of the carboxylic acid, that how they are these carboxylic acids are reacting with the or another reagents or the catalyst in the presence of the catalyst, and they are forming the different products from this carboxylic acid. And this carboxylic acid is also how they are from their structure, how the structure is modified, and it is then chemically modified, and how they are forming a product from that modification. So this is whole the learning objective and the student outcome of this topic, that is the carboxylic acids. The carboxylic acid. So the carboxylic acids are your organic compounds that are containing the carboxylic group, that is your COOH. Wherein the hydroxyl group OH is directly attached to the carbonyl group. In this there is an attachment of this hydroxyl group to the carbonyl group, and there is a formation of this carboxyl group in this. And as you can see here, the carboxyl group structures the function group, that is your COOH. So in COOH, CO is the part of this carbonyl group, and OH is the part of the hydroxyl group. So both of these form a carboxylic acid. So so how the carboxylic acids are organic compounds containing the carboxyl group. So this is the carboxyl group that is formed by the attachment of the carbonyl group as well as the hydroxyl group. So there are the three representation of the carboxylic acid is given here. That is your RCOOH or RCOOH or RCO2H. So it can be written like this also. So there three representation of the carboxylic acid is given. Next is the preparation of carboxylic acid. So how the carboxylic acid can be synthesized by various methods as follows. These carboxylic acids can be synthesized by various methods as follows. First is your by oxidation of primary alcohols and aldehydes. So here, carboxylic acid can be prepared by the oxidation of primary alcohol and aldehyde with acidic KMNO4 or acidic K3Cr2O7. So these both are the oxidants that are used in this reaction for the formation of the carboxylic acid. So this so here the primary alcohol is oxidized to the aldehyde, Then this aldehyde in the presence of this KMO4 or K2CR2O7, that is the acidic we have taken here. These are oxidized and this aldehyde is oxidized and there is a formation of this carboxylic acid. So here you can see this that this this is your alcohol, and this you can see here the alcohol. It is first oxidized in this K2CR2O7 and in the presence of this sulfuric acid, this is oxidizes and there is a formation of this aldehyde. This aldehyde is formed here. After that, this aldehyde is again oxidizes in the presence of this K2CR2O7, that is the potassium dichromate, and in the presence of this H2SO4, there is a formation of carboxylic acid. This reaction we have already discussed in the topic, that is the aldehyde, where we have used this aldehyde and alcohol both unit, where we have discussed the preparation of this aldehyde from the alcohol, means from the primary alcohol, and in the chemical reactions of alcohol, from where the alcohol is forming aldehyde, and from alcohol this ketone is also formed. So this is the one reaction that is used for the formation of carboxylic acid. Firstly, the alcohol is oxidized in the aldehyde in the presence of acidic KMO4 or acidic K2CR2O7. And second reaction, this aldehyde again is oxidizes in the presence of this oxidant, that is your potassium dichromate here, or we can take here acidic KMO4 in the presence of your H2SO4. This is oxidizes and there is a formation of carboxylic acid. From the primary alcohol, primary aldehyde, and the primary carboxylic acid is formed. Next, for example, here given, you can see here that ethanol is given here. So in the ethanol, you can see this is the ethanol, and then this is oxidizes in the presence of the potassium dichromate and H2SO4 in the formation of this acetaldehyde. So this acetaldehyde is formed here from the ethanol in the presence of this oxidant. And again, this aldehyde is, or you can say acetaldehyde is formed, which is again oxidizes and oxidizes to your ethanoic acid. So this ethanoic acid is your carboxylic acid, and this is formed by the oxidation of this acetaldehyde in the presence of the K2CR2O7 and H2SO4, and there is a formation of this carboxylic acid. So here again, for the aromatic formation of this carboxylic acid, aromatic carboxylic acid is formed by the from this benzyl alcohol. So this benzyl alcohol is oxidizes in the presence of this K2CR2O7 and in the presence of this H2SO4, which is actually the catalyst. And after that, there is a formation of this benzaldehyde, and from this benzaldehyde is oxidizes in the presence of K2CR2O7 and H2SO4, and there is a formation of this benzoic acid here. So benzoic acid is a aromatic carboxylic acid which is formed from this benzyl alcohol, which is a primary alcohol, and from here again as oxidizes reaction occurs, and in the presence of acidic K2CR2O7, that is your potassium dichromate, and in the presence of catalyst, that is your H2SO4 is acting as a catalyst here. So here this is formed this carboxylic acid is formed from this primary alcohol by the oxidation reaction. It can occur in the presence of a acidic KMO4 or acidic K2CR2O7 in the presence of the catalyst, that is your CH2SO4. Next is your from Koch reaction. So from Koch reaction is an organic reaction used to convert olefin into tertiary carboxylic acid. So in this, the carboxylic acid, in this the Koch reaction is an organic reaction that is used to convert the olefin into tertiary carboxylic acid. Means here the olefins means the unsaturated compound, or you can say the alkenes. The alkenes are also known as olefins. So these olefins are converted into the tertiary carboxylic acid, and in this reaction Alkenes are treated with carbon monoxide and hydrogen in the presence of strong mineral acid like phosphoric acid or hydrogen chloride to form the tertiary carboxylic acid. So here you can see this reaction is called a Koch reaction. It is given a name according to its scientists who discovered this reaction. And here you can see in the reaction that this is olefin, this ethene is alkene or olefin, you can say it alkene or olefin, and this is reacting in the presence of this carbon monoxide, and this carbon monoxide, the H2O means water, and in the presence of this H3PO4, that is your phosphoric acid, it is a strong mineral acid, and at a pressure of 673 K. So here a pressure is applied here and atmospheric pressure is applied here. After that there is the formation of this tertiary carboxylic acid. So this tertiary carboxylic acid is formed here from this Koch reaction. So this Koch reaction is an organic reaction. This is the organic reaction which is used to convert olefins. Olefins is your alkenes or your unsaturated alkenes that are reacting in the presence of your carbon monoxide plus water and in the presence of your phosphoric acid and at the atmospheric pressure that is your 673 K and here this strong mineral acids or you can use here hydrogen fluoride also and there is a formation of this tertiary carboxylic acid. So here you can see this ethene. This ethene is given here. This is your ethene or olefin plus carbon monoxide is given plus this is your water and from your water this is your phosphoric acid and this is the pressure and after that this is the tertiary carboxylic acid. The tertiary carboxylic acid which is formed from this olefin or get converted from this olefin. This is the second reaction of this method of preparation of carboxylic acid. Next is by the oxidation of alkyl benzene. Means here oxidation of alkyl benzene is occurring. So alkyl benzene is an aromatic carboxylic acids may be formed by the oxidation of alkyl benzene with K2Cr2O7 or acidic or alkaline amino4. So here this is your alkyl benzene. Alkyl benzene is treated with this amino4 that is the oxidant and in the presence of this hydroxyl ion and heated and in the presence of this hydronium ion. So here this alkyl benzene means toluene you can say this is reacted and there is a formation of this carboxylic acid that is your benzoic acid. So here the example is given that when toluene is heated with your KMnO4 and it is oxidized to benzoic acid. So here toluene is heated with KMnO4, it is oxidized to benzoic acid. So this toluene is reacted in the presence of this oxidant that is your KMnO4 plus potassium hydroxide and then heat is applied to here and there is a formation of this potassium salt. The potassium salt of carboxylic acid is formed here. So this potassium salt of carboxylic acid is formed here and then this is hydronium ion and then this hydronium ion when this benzoic acid is formed, firstly it is converted into the potassium salt. After that, it is converted into your benzoic acid. So here there is a formation of this carboxylic acid. Here this benzoic acid is formed from this toluene and this is formed from this toluene by the oxidation reaction. So by the oxidation of alkyl benzene. Alkyl benzene is a toluene where alkyl group is attached to a benzene molecule. So here this is your alkyl benzene. So here you can see this is the alkyl benzene and when it is reacted or oxidizes in the presence of the CmNO4 KOH and heated, there is the formation of the potassium salt of carboxylic acid and this in the presence of this hydronium ion This benzoic acid is formed here. Next reaction is here. Similarly, the isopropyl benzene. Sorry. Similarly, the isopropyl benzene is oxidizes with this benzoic acid with alkaline KMnO4. So this isopropyl benzene, which is also a alkyl benzene. So this alkyl benzene is also oxidizes or get it converted in the presence of this KMnO4 or KOH, that is KMnO4 potassium permanganate acetic KMnO4 we are using. And KOH is your potassium hydroxide. And this H positive ion is also, proton is also used here. So after that, there is a formation of this benzoic acid is formed here, and this benzoic acid is formed from this isopropyl benzene. Next, this butyl benzene, which is also alkyl benzene, is also getting converted or oxidizes in the presence of this KMnO4. That is your potassium permanganate and water molecule. There is a formation of this benzoic acid. This benzoic acid is formed from this butyl benzene. So here terephthalate acid can be obtained by the oxidation of p-xylene into with acidic K2Cr2O7. So this para-xylene means this para is methyl toluene is oxidizes in the presence of this K2Cr2O7, that is your potassium dichromate, and in the presence of this catalyst, that is your H2SO4. So here there is a formation of this terephthalic acid. So this terephthalic acid is formed from this xylene. As you can see here, the two alkyl groups that are attached to this benzene groups are getting converted to the carboxylic group. So this is known as your terephthalic acid. So here you can see this is your carboxylic acid, this is your carboxylic acid. So from this xylene, here there is a formation of this terephthalic acid. So here this terephthalic acid can be obtained by the oxidation of xylene with this acidic K2Cr2O7 H2SO4. There is a formation of this terephthalic acid. Now, next reaction is here by the hydrolysis of cyanide or nitrile. So here, cyanide or the nitriles are hydrolyzed and there is a formation of this carboxylic acid. So here, alkyl halide is reacting with the sodium cyanide in SN2 displacement to form a nitrile, which is hydrolysis converted into carboxylic acid. So this alkyl halide is reacting with this sodium cyanide in SN2 displacement. The SN2 reaction is forming, and there is a formation of this nitrile, which on hydrolysis converted into this carboxylic acid. So here you can see this is your alkyl halide. So alkyl halide is reacting with this NaCN. So NaCN, and from this CN, this substitution reaction. This is a nucleophilic substitution reaction. So from here, this alkyl halide, as in the nucleophilic substitution reaction second, you can see that from here, this alkyl group is removed. This halide group is removed from here, and from the back position, this CN will attach to this R, and there is a formation of this alkyl cyanide here. So there is a formation of this alkyl cyanide from this alkyl halide when it is reacted with this NaCN, and here the process used is your SN2 reaction, nucleophilic substitution 2, that is your second nucleophilic substitution reaction. So here there is a formation of this alkyl cyanide from that reaction, and in the presence of this HCl H2O, there is a formation of this carboxylic acid. So this alkyl cyanide is hydrolyzed in the presence of this mineral acid, that is your acetic. This is a hydrochloric acid, and in the presence of water molecule, and there is a formation of this carboxylic acid. So here R is an alkyl group and X is a halide. X is your halide, R is your alkyl group. So this was the example. So here this is given, what reaction is given here. So methyl chloride, we have taken here methyl chloride, and when it is reacting with the sodium cyanide, then from the acid reaction, this chlorine and this cyanide that will act as an electrophile. From this, there is a dissociation occurs, that is a Na positive, Cn negative, and this Cn negative will attack from the back of this methyl chloride, and there is a removal of this chloride from here. So from one side, this chlorine will remove out, and from the second side, there is a attachment of this or bonding of this cyanide to this methyl. So there is a formation of this methyl cyanide, and there is a removal of this sodium chloride. So from here, sodium, the chlorine that is removed out from here will attach to this sodium. So here there is a formation of the sodium chloride, and there is a there is a formation of the sodium chloride. Plus this methyl cyanide is also formed here, and water molecule is formed here. So here, and when this methyl cyanide is reacted with this acid or alkali, acid here we have chosen here HCl, that is your mineral acid, um, hydrochloric acid. So this hydrochloric acid is react in the presence of this hydrochloric acid. This methyl cyanide is hydrolyzed because of water is also there. So this get removed out from there, and here the OOH, this double OH is getting attached to this position. So there is a formation of this acetic acid, and this ammonia is get removed from here. So this is your hydrolysis of cyanide or nitrile. This alkyl halide is reacting with this sodium cyanide in acidic displacement, and there is a formation of a nitrile. First, there is the formation of the nitrile from acidic displacement or the acidic reaction, and after that, this nitrile is getting hydrolyzed and getting converted into this carboxylic acid. And from the cyano group that is containing a hydrogen bond, the cyano group contains a hydrogen bond which under acid hydrolysis converted into a carboxyl group. So here the reaction given means here the methyl chloride in the presence of the sodium cyanide. There is a formation of this methyl cyanide, and this whole reaction is an example of the substitution, nucleophilic substitution reaction. And after that, there is a formation of this H2O and acid, or in the presence of the acid or alkali, there is the formation of this acetic acid plus your ammonia molecule. So this is a hydrolysis of cyanide or nitrite. The next reaction is aromatic amines. So these aromatic amines with nitrous acid produces aromatic nitrite, which on acid hydrolysis produces aromatic carboxylic acid. So this aromatic amine with nitrous acid, this is your nitrous acid, HNO2. So this nitrous acid, this aromatic amine, this nitrous acid is reacted with this aromatic amine. There is a formation of this aromatic nitrile, and here nitrile will form C and will attach to it, and with an acid hydrolysis there is the formation of this aromatic carboxylic acid. So here we have taken the example of this aniline, and aniline when is reacted with this nitrous acid, and in the presence of this CuCN, that is your catalyst, there is the formation of this phenyl cyanide. A cyanide group is attached to this phenyl, and after that there is a hydrolysis, acid hydrolysis is occurring here, and after the acid hydrolysis to this cyanide, phenyl cyanide, this phenyl cyanide is getting converted into your benzoic acid plus ammonia. So this aniline in the presence of your nitrous acid and CuCN, there is the formation of this phenyl cyanide and water molecule, and they after that this phenyl cyanide is acid hydrolysis, and there is the formation of this benzoic acid plus your ammonia is formed. This is your hydrolysis of alkyl, sorry, the hydrolysis of the cyanide or the nitrile molecule. Next is your Grignard reagent. So the Grignard reagent reacts with carbon dioxide and there's a formation of a salt of carboxylic acid and which gives carboxylic acid on reaction with mineral acid. So this Grignard reagent is reacting with this carbon dioxide and there is a formation of this salt of carboxylic acid which gives carboxylic acid on reaction with mineral acid. So here you can see the example is given here. So alkyl halide is reacted in the presence of this magnesium and ether and there is a formation of the Grignard reagent. Firstly, the Grignard reagent responds in the presence of the ether and magnesium. So this magnesium get attached to this alkyl group and there is a formation of this Grignard reagent. After that, in the presence of the carbon dioxide and this acid, there is a formation of this carboxylic acid. So here R means your alkyl or your allyl group. So here benzoic acid, this aromatic compound is getting prepared for the action of this carbon dioxide on phenyl magnesium bromide. And there is a formation of this. So this is your Grignard reagent. That is your phenyl magnesium bromide. And after that it is reacted with this carbon dioxide. And this from this carbon dioxide there is an attachment of the C double O group on this phenyl ring. And there is a formation of this intermediate is formed here. So this intermediate, after that, this is in the presence of a hydronium ion. So it is getting converted to this benzoic acid. So from here, from the hydronium ion, this H is removed out from here and it gets attached to the C double O, and from here MgBr is removed out from here. So in this, you can see here phenyl magnesium bromide. This is a Grignard reagent, and when it is reacted with carbon dioxide, this carbon dioxide get attached to this position, and there is a formation of this intermediate is formed here. So this intermediate is then reacted with the acid, or you can say the hydronium ion, and there is a formation of this benzoic acid. So from here, H positive will remove out from here, and it gets attached to this position. And after that, this MgBr is removed out from here. And there is a formation of this benzoic acid is formed. So this is the Grignard reagent. In this, firstly, the Grignard reagent will form from the alkyl halide. The Grignard reagent is formed from the alkyl halide, and after that, it is reacted with this carbon dioxide, and there is a formation of a salt of an acid, and after that, it gets hydrolyzed with the mineral acid, and there is a formation of a carboxylic acid is formed here. Benzoic acid, here we are preparing this aromatic carboxylic acid, that is your benzoic acid, and the benzoic acid is prepared by the action of your carbon dioxide with the phenyl magnesium bromide, and there is a formation of this benzoic acid. So here the reaction is whole reaction is given. The phenyl magnesium bromide is reacted with the CO2, and there is a formation of this intermediate, and by the acid hydrolysis there is a formation of this benzoic acid is formed. Now next is your the hydrolysis of the ester. So the ester getting hydrolysis and there is a formation of this carboxylic acid. So this ester, the carboxylic acid can be prepared by the hydrolysis of esters either in acidic or alkaline medium. This carboxylic acid can be prepared by the hydrolysis of ester either in acidic or alkaline medium. For example, the acetic acid is formed by the hydrolysis of ethyl acetate in acidic condition. So this carboxylic acid, here you can see this ethyl acetate is reacting with this water molecule in the presence of acid. So here acid hydrolysis is occurring with this ethyl acetate, and there is a formation of the acetic acid is formed here and ethanol is formed here. So this carboxylic acid is prepared, this acetic acid is prepared by the hydrolysis of ester. Means this is your ester group COO. R is the ester group, and in this ester group there is a hydrolysis occurring and either in the acidic or alkaline media. Means in the acidic, or you can say in the acidic or in the alkaline media, the carboxylic acid is hydrolyzed, formed from the hydrolysis of this ester group. So, for example, we are given is acetic acid is formed by the hydrolysis of um, ethyl acetate in acidic condition. So there is a formation of this acetic acid. So here ethyl plus ethanol is also means what alcohol is also formed from this ethyl acetate. So this ethyl acetate CH3COO C2H5 plus H2O, and here H positive means the acid hydrolysis is occurring, and acid hydrolysis, from this acid hydrolysis the acetic acid is formed, and plus your alcohol is also formed. CH3 COOH is your acetic acid, and next is your ethanol. C2H5OH is your ethanol. Next is your by the hydrolysis of acid derivatives, which acyl chloride, acid anhydride, or the ester and the amide. So from the hydrolysis of the acid derivative of acyl chloride, acid anhydride, and the acid esters and esters amide. From this, the carboxylic acid is formed here. So the acid derivative on hydrolysis with acid or alkali form corresponding carboxylic acid. So here carboxylic acids are formed from this acid derivatives, and this acid derivative, the hydrolysis with the acid hydrolysis, this acid or the alkali hydrolysis, this carboxylic acid is formed from this. The first reaction is your by the hydrolysis of this acyl halide. So this is your acyl halide. So this acyl acid chloride are hydrolyzed with water to parent carboxylic acid. So this acyl halide, or you can say acyl halide or your acid chloride, this is reacting with the water molecule plus your acid hydrolysis. So this is water hydrolysis with the water, and there's a formation of a parent carboxylic acid. For example, is given acyl halide is reacting with this H2O. We can say the OH, the acid or the base hydrolysis is occurring here, and from this there is a formation of the carboxylic acid plus hydrogen halide is also formed here. Next is the example is given here. So here acetyl chloride is reacted with the water molecule, and there is a formation of this acetic acid is formed here. Plus HCl is formed here. So this acetyl chloride is plus water molecule, and there is a formation of this acetic acid is formed here. Plus HCl is formed here. Next is your this is your benzyl. This is your this is your acetyl chloride, and in its again hydrolysis in the presence of your water molecule, and this is getting converted to your benzoic acid. So this is your benzoic acid that is formed from this, and this aromatic compound is also formed from this hydrolysis of this acid chloride with the water in the presence of your acid or the alkali, and there is a formation of this aromatic carboxylic acid plus your hydrochloric acid is formed here. Next is your by the hydrolysis of your acid anhydride. So here acid anhydride is getting converted to this carboxylic acid. So this acid anhydride are hydrolyzed with water to acid. So this acid anhydride is reacted with this carboxylic acid in the presence of a acid hydrolysis or the alkaline hydrolysis. So this acid anhydride this is RCOOCOOR. So this is the acid anhydride structure, and when it is getting hydrolysis, acid hydrolysis or base hydrolysis, there is a formation of this carboxylic acid. So here acid anhydride, acetic anhydride plus water molecule, there is a formation of this acetic acid is formed here. From this acetic anhydride, there is a formation of acetic acid, and there two molecules of this acetic acid is formed here. So from there, there is a breakage. From here, there is a formation of two molecules, RCOOH and RCOOH. So there is a formation of this two molecule of acetic acid is formed from the acetic anhydride from the water or the hydrolysis of in the presence of the hydrolysis of acid or alkali. So there is a formation of this acetic acid. Next is your by the hydrolysis of ester. So here from the hydrolysis of ester, there is a formation of a carboxylic acid. So here you can see the esters are hydrolyzes to carboxylic acid in the presence of an acid. So this ester is hydrolyzes to carboxylic acid and in the presence of an acid. This ester, this is your ester group, and here again the acid hydrolysis is occurring, and from this acid hydrolysis, there is a formation of a carboxylic acid plus your alcohol. So here this is the formula of your ester, and this ethyl acetate, plus water molecule and acid, there is a formation of this acetic acid and your ethanol is formed. These are the three reactions or three these are the from the hydrolysis of the acid and hydride acid chloride or the ester or acetamide, there is a formation of the carboxylic acid. Next is your by the hydrolysis of your amides. So here acid amides are not easily hydrolyzed with water, but hydrolyzed easily on heating with dilute acid or alkali. Means here they are not hydrolyzed with water, but they are hydrolyzed with heating as well as dilute acids. So here dilute acids or alkali is used here, and from that this acid amides are hydrolyzing, and there is a formation of this carboxylic acid, this ammonia molecule. So here what is happening here, like from the H2O, this H2O is getting dissociated. There is a formation of H positive OH negative. Next here, this H positive will get reacted to this NH2, and there is a formation of this NH3 which get removed out from it. After that, this from this H2O, this OH will remove out from here and it will get attached or bonded to this COO, carbon. So there is a formation of this carboxylic acid is formed. So this amide, here we have used this acetamide, and this acetamide, when is hydrolyzed on heating with the dilute acid or alkali, there is a formation of this acetic acid is formed here, plus ammonia molecule is formed here. So these are the four reactions that occurs in the hydrolysis of acid chloride, ester, amides, and your acetic anhydride. Next is the reaction of a carboxylic acid. Then the reaction of the carboxylic acid can be directed to various sites of the carboxylic acid. So the reaction site on this carboxylic acids are your carboxylic group of carboxylic acid is your three sites are there. The first is the electron rich targeted by electrophile such as protons. So this oxygen is having a two lone pairs are present on the oxygen atom. So this from here the electrophile will get attached to this oxygen atom. So oxygen will be targeted by your electrophile such as protons, which are having the less electrons, or they are in need of an electron. So they will get attacked to this. They will attack to this electron-rich oxygen atom. Next is your hydrogen. So this hydrogen that is represented by the red color H. So this will get targeted by the bases. Means here the base get attached to this hydrogen atom, that is your OH negative will attack to this H positive. So H. So there from here the water molecule will get removed out from here. Next is your third, that is your electron deficient carbon targeted by nucleophile, that is shown here by the blue color. So here from here the electron deficient carbon targeted by the nucleophile. So here you can see that the electron, this carbon is your electrophile, and this acting as an electrophile because the oxygen will withdraw electron from here. So it will get positive charge. Carbon will get the positive charge. So this positive charge will this positive charge carbon will be attacked by the nucleophile. So a nucleophile which is having a property of electron donating, so it will get attacked to this carbon because it is having the less electron. So this carbon will get attacked by the or targeted by the nucleophile which is having the more electrons, and it is having the properties of the donate electron. So this carbon will get attached by this nucleophile. So the reaction of carboxylic acid can be replaced into four categories. That is your reaction at the acidic hydrogen on the carboxylic group. Means here the first is your this, the reaction at the acidic hydrogen on the carboxylic group. So here this will be targeted by the base. Secondly, it is your reaction at the carbonyl group. So in on this. Next is the reaction at the carboxylate oxygen. So here it will get attacked by the electrophiles. Next is the reaction that leads to the loss of carboxyl group. So here from here, this whole CO2 will get removed out from here. So there are four type of reactions, or the reaction of carboxylic acid can be placed into four categories. First is your reaction at the acidic hydrogen on the carboxylic group. Second is your reaction at the carbonyl group. Third is your reaction at the carboxylate oxygen. Fourth is a reaction that leads to the loss of the carboxylic group as CO2. So H positive will be moved with the base. C will be targeted by the nucleophile. O will be targeted by the electrophile because they are having the less electron, and oxygen is having the more electrons. So oxygen will act as a nucleophile to the electrophiles. Next is your whole CO2 will get removed out from. Next, the carboxylic acid are reactive organic compound because of OH and CO group and undergo many reactions. And first is the alpha halogenation of aliphatic acid. So this alpha halogenation, carboxylic acid undergo halogenation with chlorine or bromine in the presence of small amount of red phosphorus form, alpha halo and beta halo acids, and the reaction is known as Hell-Bullard Jelensky reaction. So in this reaction, carboxylic acid containing an alpha hydrogen atom is replaced by the chlorine or bromine atom to form an alpha carboxylic acid, and the general reaction is as follows. So here in this reaction is also known as Hell-Bullard Jelensky reaction, and in this reaction what is happening that the carboxylic acid is undergoing halogenation. Halogenation means it is reacting with this halogens, that is a chlorine or bromine, in the presence of your red phosphorus. Small amount of red phosphorus is also used, and there is a formation of a alpha or the beta halo acid. So on the alpha or the beta position is a attack of or a bonded of this halogen on the molecule. So in this reaction, carboxylic acid containing an alpha hydrogen atom is replaced by a chlorine or bromine. So a hydrogen get replaced by the halogen. That is why it is known as alpha halo carboxylic acid. So the general reaction is as follows. So in this, carboxylic acid is reacting with this halogen and red phosphorus. There is a formation of the alpha halo carboxylic acid. So bromination on acetic acid is a good example of this reaction. So here you can see this is the acetic acid, and bromination on bromination, there is the attack of this bromine on the alpha position, and from the alpha position this hydrogen is removed out from here. This is the alpha position is removed out from here. Again there is a halogenation, and again the bromine will attack to this position. Again there is a bromination, and there is an attack on this until there is a one hydrogen is left. Till then the bromine will attack. So from here, in the last step, you can see that all the hydrogen atoms has been replaced by the bromine from the halogen. There is a formation of this alpha halo acid is formed. Next, the mechanism, step-by-step mechanism. The first is your Phosphorus is reacting with this bromine to form phosphorus dibromide, and in the first step, it converts into the carboxylic acid to acyl bromide. So this is acyl halide is formed here, or you can say the acyl bromide. Next is your in the next step, this acyl halide is reacted from here. Again, the H positive is removed from here. And there's a formation of double bond enol is formed here. After that, this hydrogen is removed out from here, and Br will get reacted to this carbon atom. There's a formation of this compound. After that, there's a formation of this alpha bromo carboxylate. Means here Br will get moved out from here, and there is a formation of this alpha bromo carboxylic acid is formed. Although the alpha bromation of some carbonyl compounds such as aldehyde and ketone can be accomplished with bromine under acidic condition, this reaction will not occur with acid, acetic, or amide because only aldehyde and ketone analyzes to a sufficient extent to allow the reaction to occur. Next is the reaction of your COOH group. So in this first is your reduction of carboxylic acid to alcohol by lithium aluminum hydride, and in this the carboxylic acid is reduced to primary alcohol with a strong reducing agent with like lithium aluminum hydride. So in the presence of this strong reducing agent that is a lithium aluminum hydride, this carboxylic acid gets converted to the alcohol. Next, propanoic acid is reduced to propanol in the presence of lithium aluminum hydride, and propanoic acid is get converted to the propanol. Next, benzoic acid gets converted into the benzyl alcohol in the presence of this reducing agent that is the lithium aluminum hydride. Next is your this lauric acid is get converted to the lauryl alcohol. Next is the reduction by HI, that is your hydrogen iodide. Carboxylic acid can be reduced to either a primary alcohol or alkenes depending on the reducing agent involved in the reaction. Next is your decarboxylation reaction. So when an anhydrous sodium salt of a fatty acid is heated with soda lime is the NaOH plus KOH, or quinoline, it loses carbon dioxide. So here the carbon dioxide is loses from here, the whole CO2 is removed out from here, and this reaction is, and there's a formation of the alkyne. Alkane is formed here, and this is known as a decarboxylation. Decarboxylation means the removal of this CO2 from here. So there is a formation of this alkane, and the general reaction is that as this is the salt of the acid, and in the presence of the soda lime and heated, there is a formation of this alkane plus CO2 that is removed from this carboxylic acid. So again, there is a propanoic acid, and in the presence of copper, there is a formation of this ethane and whole CO2 that is removed from here. Next, aromatic carboxylic acid. So from here, whole carboxylic CO2 is removed out from here, and the formation of benzene occurs, and the Na2CO3. Next is your Handiker reaction. So in this, silver salt of fatty acid and heating with halogen undergo decarboxylate halogenation, give alkyl or aryl halide. So here also the whole CO2 is removed out from here, and for example here given the salt is given, and after that there is a formation of this benzyl bromobenzene is formed. Next, electrolysis. So in this, the electrochemical oxidation of sodium or potassium salt of fatty acid gets alkane, having twice the number of carbon atoms present in the alkyl group of an acid, and this is known as electrolysis. So in this, you can see the electrolysis of potassium ethanol forms ethane with carbon dioxide gas and hydrogen gas as a side product. So here ethane is formed here. So here you can see here at cathode there is a formation of this hydrogen gas, and anode there is a formation of this acetate. This this alkyl is formed here alkane. Next is the question. So acetic acid is obtained in which of the given reaction takes place? That is a C-acetylaldehyde oxidized by production by phenol and sulfuric acid. Acetic acid is manufactured by fermentation of which of the following reaction? That is the ethanol. When benzoyl alcohol is oxidized with amine for the product formed with the benzaldehyde. Next, which of the following give benzoic acid on oxidation? That is a benzyl chloride. Next, in the below sequence of reaction A and B of which of the following is formed? That is A is formed. Next, formic acid is obtained when which of the given reaction occurs? That is a C. Glycerol is oxalic acid is 110 degrees centigrade. Arrange the following group in the decreasing order. in this option A is correct. These are some of the references from where you can study this topic, that is your carboxylic acid. And thank you so much for today's lecture.